What's up, YouTube? How's everybody out there doing? Hello again. I'm Greg from GregsTutoringNYC at gmail.com. So I'm doing a little series here about hardest math problems, with the criteria being that I went through some past New York State tests and found some of the hardest problems that there are. And I defined hardest as the number of kids, more kids who got more wrong. Okay, we're live, so let me close this down. I found the hardest problems that kids were getting wrong the most. Okay, and that's how I'm defining hard. I looked at grade 3 already, so that's already out there. I looked at grade 4 already, that's already out there. I did 2 parts for grade 5. This is probably going to be in at least 2 or 3 parts for grade 6, because there's that many more problems. Grade 6 is now, quote, middle school, so things are bumping up a lot. I see a few people in the lobby. Welcome. Hello. So the way we're going to do this is you can ask any questions you want. I would prefer this to be interactive. If you want to remain quiet, that's cool too, though. And if you're catching on this replay, as I go through the problems, you can pause it and then see how I solve it. When possible, I'm going to try to solve the problems in multiple ways, including just using logical ways in addition to arithmetic and algebra. So at grade 6, it's kind of the line in the sand. You're in middle school now, and the problems are starting to get harder and more cognitively detailed, that kind of a thing, all right? So that's where we're going to be here. And also, like I said a minute ago, things are getting harder. So if we're doing grade 6, it means you should be proficient in grade 3, 4, 5, also in kindergarten, first grade, and second grade. So the way I'm working this is that the assumption is whatever grade you are, you're totally proficient in the grade before, you're as proficient as possible in the grade you're at, and you know some things about the grade above you. So if we're going to do grade 6 now, you should be clear through all of grade 5, through a lot of grade 6, and you should know some grade 7 stuff, okay? And that's the way you should increment through all your, with English, social studies, whatever the case may be. That's really where you should be in science, so that you're not just average at grade level. You want to bump up your game all the time to really get out here. And even though I'm taking this view that we're approaching this from questions, I'd rather we look at topics, okay, and concepts and solving problems. That's the perspective we're at. So that you're thinking and using your brain, and even though I'm using a state test as the focus here, we're not looking to do this to solve, to be proficient in a state test. Although if you know the topics and the concepts and how to solve problems, you will also be proficient in doing something like solving a state test. And on that note, by the way, part of the inspiration of doing that is in New York, we're having state tests this week, and it's the math ones. So I'm just trying to do this series. I actually don't think I'm going to finish it because I have to go up to grade 8. So by the time I get to grade 8, I think the test will be over. But I think these are still useful videos. On that note, even though I pulled the information from New York, it should really apply to anywhere in the country, or really anywhere. If we're going to talk about the number line is the number line wherever you're at and whatever level you learned it at. You start learning in the number line really in second grade, mostly, at least in the United States, and then things that inch along. You learn about thermometers, a topic like exponents, at least in the US. You know what an exponent is, like you should know what squaring is, like 3 squared. But you don't necessarily know all the details, like what's 3 squared times 3 squared. You might know to do 9 times 9 and get 81, but do you know that's really 3 to the 4th? That kind of a thing. So the topics can move back and forth across grade levels. I think one of the problems we have, even through the world, but certainly the U.S., is that subjects are taught per grade, which means per age, really. And it doesn't necessarily need to work that way. There's no reason a younger kid can't be in a more advanced class if they're understanding the material, if they can deal with the acceleration, if they have the intellect to handle it, all right? So when possible, when we're addressing these problems, I want to look at critical thinking and problem solving and stuff like that, as well as a lot of you just have problems taking the English words or looking at a chart or illustration and just deciding what is going on there, right? So it's not even all the time when you get a math problem wrong, it's not even just the raw math. That you might understand. It's the mapping between English and math and vice versa. It's also the mapping of how to choose, you know, if there's an expression you see like x plus 5 equals 9, you may know what to do there. But if it's in words, like I have a bunch of pens and I had 3 to them, and I ended up with 5 pens and 6 pencils. Like how many whatevers did I have? That ends up confusing people. So with there's multiple mappings happening simultaneously. We also need to worry about stuff in our short-term memory. Okay? So as a general guide, when you're solving a problem, you don't want to do as much as it you can unless it's instantaneous stuff. I gave an example yesterday, like 12 times 10, 2 plus 2. That stuff, that's rote and that's memorization. I want to less concentrate on that as we're going over these and actually concentrate and actually solving problems. Okay? So that's what we talk about, hardest problems. What are kind of the hardest problems to solve? And of course, we're at grade level. So grade 3 is not going to be as hard as the 12th grade in high school, right? So there's things like that. All right, I see a few people in the lobby. Welcome again. I'm Greg from Greg's Tutoring NYC. You can check out my website. You guys can email me about anything. I specialize in admissions tests, but I also do homework help. And I normally concentrate on math and English, but I do other subjects as well. I used to be a professional programmer. I had gotten sick a couple years ago, so I kind of put that on pause for a little bit. But I know a lot about computers as well and computer programming and things like that as well. So there's a wealth of stuff I can offer people. And even at that, when you're trying to write a computer program, you don't just necessarily sit down and pound out code. The same as if you're writing something. You don't necessarily sit down and you want to write Harry Potter. You don't just sit down and start like, it was a dark and stormy night, and then ends up at he kills, you know, oh yeah, da da da, and by the way, he kills Voldemort at the end. You know, this is a methodically thought out thing that you have to do. So we're trying to do that at a minute level, okay? But we still need to rethink things through. So it's important to me that you're sitting and analyzing something, really get at the analytics of stuff so that you can debug it and figure it out, whether it's a computer program or solving a math problem here. All right, so with all that pre-information stuck in here, let's kind of start jumping in. So what I'd like to say again is that this is grade 6. So it's kind of the point where you need to bump up your game a little bit. Whoops. So the first thing we're going to look at is this reference sheet. So in New York, at least, when we have a state test, they give you a reference sheet. This, even though I'm going through this, is because it's based on a state test. This is what basically New York is asking a 6th grader to know. And they're giving this to you here. But the truth of the matter is, it's not as useful as it looks. Because the truth of the matter is you should know these things. Okay? So maybe kids don't know about inches to things here, but you should know this here, that a mile is 5,280 feet. You should be able to convert this. If you know that 3 feet is a yard, you should know that a pound is 16 ounces. You should know that a ton is 2,000 pounds. Okay? In the United States, we're not really still too stuck in miles versus kilometers and so on. So if you need a reference sheet to do that, because we actually don't do this conversion too much in the United States, this might be the useful for this. Okay, there's also the capacity conversions. There's the so-called US capacities. Well, at least up to here. That you guys should know what these are. If not, it's here for reference. So since this was based on a state test, what happens is there's nothing like test day, and your adrenaline kicks in, and a lot of kids freak out, and they kind of start don't remembering stuff. So at least they can offer you this. A question based on this is not too often on these kind of exams. They might be in your classroom, but it's still, if you take a page like this and send it to yourself in email, okay, or put it on your tablet on an SD card or whatever. If you just look at this twice a week, once a day, when you're on the bus or the train, while you're eating breakfast, as soon as you wake up, you know, there's a whole bunch of ways to memorize these things that are not really adverse ways. and that if you just looked at this once a day for a month on, as you're waiting for the bus to come, or a thousand things. This is not hard to memorize. The same goes for some of the formulas. Okay, this is basically indicating that you only need to know the area of a triangle and the volume of a cube and so on. But the truth of the matter is there's also other formulas that you're supposed to know, like the perimeter of a square, the area of a square, the perimeter of a rectangle, how to get the area of, well, they're giving it to you for the triangle. So there's a lot of assumptions here. So basically this reference sheet is incomplete, and there's a lot of things they're assuming that you know already, all right? And by the way, I give some more to my own students, which I send them some conversions and some other information. If you guys would like a copy of this, please email me, and I could send you a link to it, or I could put it up on my site and give you the link to that, or just attach it in the email. All right. So there's that. But this is something you need to know to be solving problems. Is some of the basic core kind of detail info. All right. So with that in mind, let's jump into here. Let me just make sure that we're actually live, because YouTube, I've done YouTubes where it's died on me, and I'm talking into the wind basically. All right, give me 1 second. My computer is freaking out for some reason. Okay, so question number 18 here. A high-speed elevator can rise 480 feet in 30 seconds. Which expression represents the rate in feet per minute on the elevator? So what have they given us? They gave us, whoops, wait 1 second. I think I realized what happened. I just loaded an app without realizing it. So an elevator rises 480 feet in 30 seconds. So that in implies we have a ratio going on. 480 feet. Okay. Per, as an in, right? 30 seconds. Okay. And then the question is, which expression represents rate in feet per minute? So we have feet per half a minute, right? 30 seconds is half a minute. So it seems to me that we need to get 60 seconds. So how can we do 480 over 30 equals something over 60, right? That would be a minute. Well, we're going to double it. We're going to do 480 times 2. Because we doubled the bottom, right? Okay, and that's going to give 960 over 60. Okay, so that's the way you would answer it if you did. So now we look at the answers. Well, none of those answers is my answer here. Okay, because we're trying to look for 960. None of those is it. But if we look at choice C here, that's what I did. I just doubled the 480. Because it's 480 feet in half of a minute, then how many is in 1 minute? Okay, all right. So I don't know how kids answer this wrong, but the majority of kids answer this wrong. I'm guessing that they probably chose B here. That's my wild guess, is what some kids did. They didn't really understand it, and that the wording to them was odd. But remember, if you take a sentence at a time, and I always put this bar at the end of the sentences, even myself. An elevator rises 480 feet in 30 seconds, and I stop, and I think about it. What is going on there? Oh, it took half a minute to rise 480 feet. I might actually say that to myself without even knowing what the question was. Oh, 30 seconds? That's a good number. It didn't say 28 seconds. So you have to kind of be astute when you see numbers like that and really try to understand what might be happening there. Why did they say 30 instead of whatever? And it might be random. It may have nothing to do with anything. But one of the things that's also true of a lot of the tests is, there is, as tricky as it might be, they're kind of really not trying to trick you. And I keep saying the word test. This is not about test, but any problem. It's just about solving it. It's trying to take a description and try to model it in math. Okay? So we have 480 feet in 30 seconds. How much in a minute? Oh, 30, 60. So it's double. Then it's 480. That must be double 480. So we're gonna get C for that. All right. Okay, so this switches gears into geometry. So my rule of thumb is to forget the words originally and just look at the illustration. And often what happens is when you look at the illustration, you half solve the problem. In some cases, you completely solve the problem just by analyzing the illustration. What happens is if kids look at the words, some kids just to go through the progression here, will say, okay, Erica drew the parallelogram and go, oh, that's a parallelogram? Okay, I didn't even know that. And even the kids who did it, oh, okay, there's some numbers there, cool. Which expression can give the finite area of the parallelogram? What you do, you almost made the illustration like it's a sidebar that's not important, okay? But the illustration is just as critical as all the words. In fact, it's giving you details. There's a 4.5 there that's important. That's the length of one of the sides of the parallelogram. There's a 5 1/4. That's the length of the side of the base of the if we look at this as length versus width, right? And then this number here, the 5 1/4, with the dotted line. So it's saying the height of this is 4 1/4. I said 5 1/4. Sorry. By the way, I have dyslexia, and I also have slight dysgraphia. So sometimes numbers play tricks on me. So it's more critical for me, and it can get in tune with some of you guys for not understanding stuff. And it's something I must be aware of when I see a number on a page, that it may actually not be the right number that I'm seeing. And if I look a second time, it could actually change. It's almost like it's a CGI thing that's changing before my eyes. So a minute ago, I literally saw 5 1/4. So that's my cross to bear, right? And here I am with that problem trying to teach you math. So it's something that you have to train your body to figure out, what are my strengths and what are my weaknesses? And there's no way I can fix this problem, okay? So I just have to adapt and work around it to be sure that when I see numbers, it's really the number my brain told me it was, okay? So, and you guys need to be aware of your own strengths and weaknesses. Yours are going to be different than mine, okay? And in the event the 4 1/5 is a height, okay? So we're going to look at the parallelogram as an illustration. So they give us this, they give us that, okay? It's a parallelogram, so that means this must be 4 1/2, and this must be 5 1/4. But it would be clear, I saw both of these numbers originally as 5 1/4, just to be clear what I was talking about a minute ago, okay? Which wouldn't make sense, but in any event. So this is parallel to this, and this is parallel to that. That's what a parallelogram is defined to be. The opposite sides are parallel to each other. And the height of this parallelogram is 4 1/5, okay? And we can prove this. Okay, I'm going to take a little sidebar in describing this here. And by the way, we're going to go about an hour and 15 minutes. I'm probably going to break this whole series in at least 2 parts, and I have a feeling it's going to go into 4 parts. In the event if we take the parallelogram like this, okay, if we drop this down, okay, and we call this A, this part of the parallelogram here, by the way, that was a straight line straight down, and we call this B. If I take this triangle and shove it right there, okay, and I'm going to dot line there, and it's not the same as the dotted line that was originally over here. It's not the same as that dotted line. If I take this and remove it, what I ended up with is a rectangle, okay? And you all know that the area of a rectangle is equal to length times width, okay? So that's why this height is important. This height here turns out to be the same height there, okay, which turns out to be the width. So it turns out that a parallelogram that looks slanted like this is actually if you do some geometric transformations, is you could force it to be the same area as a rectangle, okay? So that means the area of a parallelogram is equal to this number here. We'll call that the length. The length times the height, okay? All right, so that means when they say find the area here, we're going to do 5 1/4 times 4 1/5. Okay? And now it's asking what it is, and that's literally what I just wrote here. Okay? Some of these others are misunderstandings of using a triangle. So if you notice, the inside here is actually the same as answer A, but it's taking half of it. No, the half only applies to other geometric shapes, a triangle, a trapezoid, other things like that. So it's not applying here. This is twice. No, this is not right. If we work on that it look like a rectangle, we can make an equivalence of a rectangle. There's not 2 rectangles, so that's no good there. All right. And this says 5 1/4 times 4 1/2. This 4 1/2 is this number here. Okay, that's no good. Okay, it's not the length of the side. It's not length times width. In the rectangle, it's length times width, because we placed the length of the rectangle is the same as the height. Okay, it's the height that's at our key here. Okay, not the length of this side. So that the length of that side might be important for getting the perimeter of this parallelogram. All right, but not the other thing. By the way, please subscribe to the channel. Please like the video. Let me just check that we're still live. Okay, so let's do the next problem. So by the way, if you notice, this area of the parallelogram was not on the reference sheet. So this is something you need to either memorize or know that this transformation I did with the rectangle over here is going to be the case, okay? And I just accidentally turned off my tablet, so give me a second. Okay, this is one of those problems that's either a complete no-brainer to kids or they don't know what to do at all. So enough of you are going to know that immediately that the answer is C. So for those of you that's the case, that's cool. So the goal here when we have an algebraic expression like this is to get the symbol by itself. That's R. So if we divide both sides by 0.3, right, that will cancel out. And we're only left with R on that side. Okay, so then we got R equals 2.1 divided by 0.3. Okay, so if that doesn't leap out to you that that's 7, then let's actually do the long or the shorthand division. We have 0.3 divided into 2.1. Okay, I don't like to use decimals, so what I want to do is I'm going to move the decimal. So every time I move it on the outside, because my goal is going to try to make this a whole number, because I don't like to divide by whole fractions and so on the outside. So I try to metabolize that so that's the case. So for every movement I use the decimal point here, I'm going to move it here once. So if I move it over here once, I get 3, so I'm done. So the problem resolves into 3 divided into 21. And if now you don't know that's 7 and you're done, then there's a bigger problem than actually trying to solve the original problem here. Okay, so the answer is C, no matter how you slice this. And by the way, just to double check it, if we go back into here, that 0.3 R equals 2.1, right? If we do that, if we work that through, 0.3 times 7 equals 2.1. This tablet gets to be horrible. We're going to get 0.3 times 7 is 21, and we have 1 decimal place. So we move it over, right? So 2.1 is equal to 2.1. All right, and there you have it. This one wasn't too bad in the number of kids who get it wrong, but it's still one of those ones that you have to be careful. So I'm assuming, again, I don't have the analysis. I'm assuming enough kids said that the answer was A. Okay, but that's wrong if you double check it, because it means we have 0.3 times 0.7. Okay. So if we multiply just the digits, we get 21, right? And then we need to move it once for here and a second time for there. So this is basically 21.0. We go dot, dot. And we get .21, okay? And that's definitely the wrong answer, okay? Because it was 2.1, not .2.1. So again, you have ways to take your answer and feed it back in once you determine what it was or not. Okay, so this one is almost set up for us. I kind of like these to one extent because it kind of leads us through the process of resolving the problem. Okay, so we normally have a statement, and then we can take each bullet by itself. It's kind of cool, calm, a collected approach through the problem that way. Okay. So Madison and Pedro each created a number pattern that began with the number 0. One second, I got a message here. All right, sorry. So each had a pattern that began with the number 0. So we're doing something, we don't know what, we're starting with a 0. Okay. Madison uses the rule add 4. So something is being plus 4'd. And Pedro uses the rule add 12. So Pedro is plus 12ing something. Okay. So we don't know what to do here yet. I can make some observations just without knowing what the question is yet. We're starting from nothing, and this may not be important, but we're starting with an even number from Madison, and Pedro also an even number. I'm also noticing that there's a multiplication by 3 here. So again, these may not matter, but at each step, I'm just trying to figure out, like, where is this problem going? What can I understand about it that may or may not end up helping me with actually solving what the question is going to end up being? Okay, so I'm just making mathematical observations, making sure there's no terminology here that I'm confused about, and so on, right? Because it mentions a number pattern. So it looks like something's going to happen here, like they're going to add 4 and add 3, maybe starting with a 0. Okay, we don't know yet. Okay. So which statement is true about each corresponding pair of numbers in the 2 patterns? So I believe they're going to give us something that's going to involve the plus 4 and the plus 12. I believe these are the 2 patterns they're talking about. Okay. So, and I'm going to guess now that I saw the question, again, without seeing the answers, is that Madison's going to go 0, 4, 8, 12, right? And Pedro is going to go 0, 12, 24, 36. Okay? So let's see if that is what's going to happen here. And I'll admit, at this point, I've gone overkill. I don't know if this is where they're going. I'm just trying to kind of give you guys a heads up that you should be familiar with it. You've been in your math classes now for 6 years, at least. You might even be interested in math and gone further than that. and you kind of know where kind of things go and how the problems are set up and so on. All right, so let's see. Each number in Pedro's pattern is 8 less than the corresponding number in Madison's pattern. So what are they talking about there? Okay, so it turns out that there is a table like this built somehow. So it says each number in Pedro's pattern is 8 less than the corresponding number. So if we compare this 4 and 12, that's the difference of 8. If we compare the 8 and the 24, and in fact, let me line it up. So that's Madison, that's Pedro. And it could be that this is not enough data yet, but let's see if we can grok anything just by having the 3 inches like this. So each number in Pedro's is 8 less than the corresponding number. So corresponding means this column, right? These are rows going this way in this column. So it's the first number of Madison versus the first number of Pedro. So that's true, and the first one is true. On the second one, it's not true. So then the answer is not A, okay? Let's try B. Each number in Pedro's pattern, that's the second line, is 8 more than the corresponding number in Madison's pattern. Oh wait, by the way, I read B as A. So it turns out A was completely wrong. B is what I was just addressing. So that's false as well. Okay? Each number in Pedro's pattern is 3 times less than the corresponding number in Madison's pattern. 3 times less? No, Pedro's pattern is more, so that's no good. Okay, and then each number in Pedro's pattern is 3 times more than Madison. So 4 times 3 is 12, yep. 8 times 3 is 24, yep. 12 times 36 is that, yep. And by the way, the original number of 0 and 0 also works for D, because 0 times 3 is 0. So for that reason, the answer is D. So this is a time waster problem. First of all, this kind of obtuse setup of the pattern and mentioning corresponding pairs and 2 different patterns, and you have to go through it. And I made a little slip up there. And again, the key of making a slip up is to know you made it, okay, and to be able to fix it almost instantaneously. All right. All right, and then just make sure that your pattern's correct on something like this. You could have made a goof up over it, and you could have wrote this as maybe 26 or 35. And they're like, oh, the rule doesn't work. Go back, reread it. In fact, even once you get the answer, go back and reread the problem to really make sure that's what's going on and that you're answering the correct thing on that, okay? Okay, a lot of kids get this question wrong. So this is kind of part of what we're doing here. And it's about your mastery of the subject, about your astuteness, about your being attentive, okay? So this is kind of agnostic. It's neutral to math. It's about problem solving again. It's about something conceptual. It's about thinking something through, okay? Which is why a lot of kids get this question wrong. So we're going to start out, we're going to look at the illustration, not the words. What do we have here? It kind of looks like a Rubik's Cube. Now, to some kids, this is an optical illusion. All right? So it turns out it goes 4 high, 2 deep, and 5 across. To some kids, they think this is a cube. This is not a cube. A cube has all the length, the width, and the height is all the same. So there's nothing they're telling us here, but let's kind of label this. There's 2 cubes here. Okay, the height here is 4. Okay, and this length in the front is 5. Okay? So normally the volume of a cube is the length times the width times the height. Okay? This is not a cube. It's a right rectangular prism. But it turns out the volume of this is also the length times the width times the height. Okay? So I don't know where they're going. So we have a cube, it's not labeled. Oh, sorry, we have a rectangular prism, it's not labeled. So let's just go through that. There's nothing more to grok from this. The right rectangular prism is right rectangular because every corner has a right angle to it. Okay, even on the faces that they didn't show us. Okay, so every angle corner on the sides there, including inside each little cube. So each little thing here, that's a cube. That's that. Whoops, sorry. What did I do there? This little bugger here, or I could fill in this guy back down there. That's definitely a cube. So there's a whole bunch of cubes making up this right rectangular prism. Okay. So the right rectangular prism shown below is made of equal sized cubes. So it's talking about these little guys here that I just was referencing to. They're all the same size. Okay. The side length of each cube is 2.5 inches. Wait, what are they talking about? I just gave that this was 2, this was 4, okay? And this was 5. Now they're saying it's 2.5? What's going on here? Okay? I only counted the number of cubes. So it was 2 cube units, if you will. That's the width. It was 4 cube units going up and down. It was 5 cube units going left to right for the length. Okay? But they're telling you that each little cube inside here, in other words, this length here, let me change the color so it's clearer. This little length here, from here to here, that's 2.5. Okay? So with that in mind, let's go back and revisit some of this. If that's 2.5, then this is really 5 inches, right? Because 2.5 times 2 is 5. Okay? If this is 4, then it's 2.5 times 4, which is 10. Okay, and if this is 5, what do we get there? 12.5? If I did that right. Yeah, 2 times 5 is 10, and half times 5 is 2.5, so we get 12.5. So now we kind of rechange the dimensions to 10 by 5 by 12.5. Okay? So now what's going to ask us, what is the volume in cubic inches? So now we're dealing in inches. We're not doing cubic units anymore of the right rectangular prism. Okay? So we're going to go back to the volume equals the length times the width times the height. So we're going to get 10 times 5 times 12.5. Okay? It's easy for me to see that 10 times 12.5 is 125. Okay? So we have 125 times 5. You guys should know that that's 625. Okay, this is part of your math that you should be proficient in now, which would give the answer of D. If you don't know it, you go on the side and you do 125 times 5, right? 5 times 5 is 25. Carry a 2. 5 times 2 is 10 plus 2 is 12. 2. 1. 5 times 1 is 1 plus that is 6. Okay? So you have ways to do this. All right? So We just approached this methodically. We took it one step at a time. To me, again, the key was not to look at the words and then get lost. Look at the figure, as little information was there, and just start feeding it in and building it up as you can get stuff. And sometimes in problem solving, you have to do experimentation. If you don't know how to solve something, start from somewhere and then just start adding information until it starts making sense and so on. All right? All right, let me see how we're doing on time here. We're going 40 minutes, okay. Let's see how far we can get with some of this stuff. Okay, so again, we have a problem here. We're going to look at the illustration first. I see there's 6 Maple Street, which I believe is this house right here. Okay, and it's on Maple Street. Okay, I believe 4 Oak Street is this house, and it's on Oak Street. Okay, I don't know what's going to go on here next. This looks like Oak Street is the next street over from Maple Street. They might have nothing to do with each other. It might be 10 miles away. Let's see. Maple Street is showing 1, 2, 3, 4, 5 houses, and Oak Street is showing 1, 2, 3, 4, 5 houses as well. I don't know if that matters. They are different kind of houses. The one on Maple Street looks like it's like a 3-story house next to maybe a 2-story garage. Not sure. The one on Oak Street, they seem to be larger. A larger garage with a tinier house. Probably has nothing to do with each other. The Oak Street ones have chimneys. I don't know if they want to count rectangles here or what. We don't know. So there's not too much other information we can grok out of the illustration, but at least we looked at it. There's also dashes through the center of the street. I don't know if that's going to come into play, right? Just analyze it and just get a feel for what's going on here. So the picture below shows 5 houses. We already said that. On Maple Street, cool. And 5 on Oak, cool. So that doesn't really reveal too much info to us, because the illustration already tells us that as well. So it's cool, it confirmed it. So each house number on Maple Street has 6 more than the house number to its left, right? So what are they talking about here? They're talking about the address, okay? So that means if each house number has 6 more, that this number is 12 Maple Street. This is 18 Maple Street. Okay, this is 24 Maple Street. And this is 30 Maple Street. Be careful with something like this. It's easy to make a silly error and goof up. And again, it's about your mastery and your attention and your astutness. Really nothing else. Just focus on nothing else in the world except for this question and this problem. You're counting by 6s. There's no reason to make a mistake here. So 6, 12, 18, 24, 30. If you don't know your multiplication table in grade 6, do what I said earlier about the reference sheet. Put a multiplication table on your tablet or your phone or your laptop or your computer, and every day just look at it. For somebody who truly really doesn't know your multiplication table, please email me. I will work with you on learning how to do it. It's really easy to do. If you take even up to 12 by 12, you already know half of it. You already know the 1 times table, right? Don't tell me you don't know 5 times 1. You already know the 2 times table. Don't tell me you don't know like 9 times 2, okay? You already know the 10 times table. Just add a 0. So you already know 36 numbers, right, out of 144. Okay, there's others in there that you know as well, all right? Because if you know 2 times 9, you also know 9 times 2. So there's parts of like the 9 times table, you know, the 8-part table, you know, the 7 times table that you know, and so on and so on. So there's ways to do this, and I can show you how, where you could have the multiplication table memorized in no time. It's not a hard thing, and it's a travesty that your grade 3 teacher, at the least, didn't solve this. No less your 4th grade teacher, your 5th grade teacher, and even your current 6th grade teacher. There's teachers knowing that you guys don't know your multiplication tables, and even of those who use your fingers or doing it fast, you're wasting your time and you're doing stuff that are error prone. Commit it to memory and never worried about it again for the rest of your life. Okay? All right, so then we're going to do here now. So each house on Oak Street is 8 more than the house was up. So if this is 4, this is 12. Okay, it's 8 more. So 12, that's 20. And this is tougher numbers. This is 28. Again, 28 plus 8 is 36. Okay, so this is what I would do at this point where you label these. Go back and revisit everything. Each house number on Maple Street is 6 more. 6, 12, 18, 24, 30. Cool. Each house on Oak Street is 8 more. 4, 8, 20, 28, 36. Cool. You double checked it so that now when you come to the question, you can get some sense out of it. So how much greater is the house number of the last house on Oak Street than the house number of the last house on Maple Street? So they're going to compare these two right here. Okay. So how much greater is it? It's 36 versus 6, or 6. So that gives us B. And we're done. We're done. We had a problem that looked like could be nasty and bent out of shape because I had this illustration. And there we go. So this is kind of a long scenic route to just asking us, like, what's the 5th number of a pattern? What's the difference between the 2 5th numbers of 2 different patterns? Okay. We also had the pattern that we just did with Pedro and Madison, right? Where they could have asked something like that with that problem too. Okay. Where there was a +4 and a +12. You know, they could have asked us on that problem the same thing here. And we would have been comparing 12 and 36. So the difference between those two would have been 24. So there's lots of tweaks, lots of different approaches they can give to these questions. And it's just about processing it, figuring out what they threw at you, and just try to figure out how to get to the next step with it. Okay? Again, if anybody wants to join in and ask questions about what I'm doing here, cool. If you have questions about something I'm not talking about, I will probably not answer them until the very end, or you can email me questions. I'm very open to helping you guys. Okay, so which expression is equivalent to the expression below? So technically, this is our illustration. So we have 1, 2, 3, 4, 5, 6. We have 6 G's. No brainer? Yeah, we have 6 G's. That's what it is, 6 G's. Okay, we also know, just to show another way, that multiplication is repeated addition. So G plus G is 2 G's. So add another, we get 3 G's. Add another, we get 4, another 5, another 6. Okay? This is not G to the 6. This would be G times G times G times G times G times G. Okay, that's with multiplication. That is not that. Okay? Okay, this is just an out of space. Okay? I could see some kids saying A. Okay? But this is G plus G. That means 2 G's. Right? If I had a pen plus a pen, I don't have 2 plus a pen. I have 2 pens. That's what's going on with C. All right? So the 6 is a constant. But we're getting multiple G's here by adding them together. So that's a no-go. Okay, so here we have a word problem, right? And we notice this fraction stuck in the middle of it somehow, right? So in our teacher had 2/3 of a gallon. So note that it gives us gallons because we may have to do unit conversions that are poured in containers. What about the containers? if the art teacher poured 1/8 of a gallon of paint, the same paint, into each container, okay, until he ran out of paint, how many containers had paint in them, including the one that was partially filled, okay? So they're telling us that he's going to run out of paint and that the last bucket or container he has won't be filled up to the top, all right? So let's forget about the fractions for now. Let's say I had 10 gallons of paint, right? And I had a container that accepted it. So I have a total for that, and this is my container. Would I not do 10 divided by 2 to solve this? So what I did was I avoided the question. I took a sidebar from 13, and this is the way I would solve it myself. All right, thank you. This is the way I would solve it myself. Somebody just got me soda, guys. I would take the complexity of the problem here and replace the numbers they gave me by what I would consider simpler numbers. So I'm going to replace the 2/3 and the 1/8 by the 10 and the 2. Okay? Sorry, wait, I put 5 on here. It'll be 10 over 2 equals 5. So if I had a total amount of paint of 10 gallons and each container could hold 2, wouldn't I need 5 containers? So I have my model set up right here. So if my total is 2/3, and this is what I would do. This is how I actually do this sometimes. So my total is 2/3. My container size is 1/8. Okay. So I'm actually going to write 2/3 divided by 1/8. Okay. Now some of you might be able to get as far as this and then not know what to do. So there's another way, an equivalent way to write this, which is 2/3 divided by 1/8. Okay? And division by a fraction is the same as multiplication by its reciprocal. So we end up getting 2/3 times 8/1. And that's equal to 16/3. Okay? 16/3 is 5 1/3. All right? So it turns out they give us 5 here and 6 there. But remember this thing here. It said even the partially filled ones. So there's 5 full containers, 5 full 1/8 size containers, and another container with only 1/3 of it full. So that's 6. So the answer there is D. All right? So hopefully most of you will be able to get that. Hello, Cal. What's up? All right. So let me move this to the next question. And by the way, this is a standard kind of question you get asked, certainly on standardized tests, but certainly if you're in your classroom and your homework. This is what I call a pattern question. This comes up a lot through many grades with different complexities thrown onto it. But this is the base question you have to deal with. In fact, I think we had some of these yesterday for grade 5, where it's asking like the length of a ribbon and so on. All right, and this might even come up again in this group of questions here. So illustration here is 4 numbers separated by commas. We have 2.5, 3.2, 2.7, and 2.3. There's a bunch of numbers there. We don't know what they're going to ask us to do. They may have us add them, right? So you can see there's no way this would add up to, say, 100. There's 2.5, 3, that's about 5.5. About 3, that's 11.5. These numbers add up to about 12, okay, if we would estimate them, all right? They may ask us to put these in order. So it would be 2.3, 2.5, 2.7, 3.2. They may ask instead of the least to greatest to do greatest to least. Then it would be 3.2, 2.7, 2.5, and 2.3. They may ask us to put these into a number line. Now, I already know they're not going to ask us to do that because we would see number line choices for A, B, C, and D. All right. So what are they going to ask us to do? So now that we've analyzed this, let's go look at the words. A shelf has 4 books on it. Cool. So each of those represents each of the 4 books. So again, I take these a sentence at a time. So I stop. What's going on here? Each of these is 4 books. Cool. The weight in pounds of each of the 4 books on the shelf is listed below. So this is pounds. One book was 2.5 pounds. Another was 2.7, and so on. Okay. Which inequality? Okay. An equality means something like x equals 5. Okay. An inequality involves less than, greater than, less than or equal to, greater than or equal to, and not equal to, which is the equal with the slash through it. Okay? So these are the ones you guys have learned. So which inequality and choices, so if you notice that the choices are only using these 2, represents the weight W, right? So this W one time, book 2W, the book 3W, the book 4W. Okay? I've chosen from the shelf. Okay? So W is greater than 2.3. So we definitely need to put these in order. Okay, and again, you're better off not doing this in your head. Always write stuff out, especially if you're doing it on a test. But even when you're not, if you're just doing homework at school too. So W is greater than 2.3. Okay, that seems to be the case, and enough of you would say that was what the answer was. But it says greater than, not equal to. It didn't use this operator here. So then the answer is not A. I have a feeling enough kids, when they originally did this, that's what they did. They just said, oh, it's 2.3 and above. But that's not what A says. A says it's only above 2.3. It doesn't include 2.3. Okay? W is less than 2.4. That would put it over here. No, that doesn't seem to be an equality we're shooting for. So that's completely ridiculous. And then W is greater than 3.2. That's numbers from this point on to infinity. Okay, that's not the 4 numbers. The set we're looking for is inside of here. That's the only 4 numbers we're looking for. Okay, so that rules that out. And then W was less than 3.3. Well, yeah, the next decimal up would have been 3.3. And it turns out that these numbers the 4 of these are less than that. Okay, so that would be the case. You might argue, well, doesn't that mean a book could be 2.1 and that's not part of the set? It's not what it said. Read the questions. It's only talking about these 4 books. It's spelling out the set. So for this set, W is less than 3.3. Okay? It's also greater, in this case, W is greater than 2.2. Okay? Now, it would have been nice maybe if it added that to there, but it didn't have to. If you read the question clearly and concisely, that's part of what's going on about there. Right. Very good, Serena. Please like and subscribe, anybody in the lobby. If you want to keep quiet, that's cool too, though. You can always email me, guys. Please subscribe and like. Please subscribe and like. Please subscribe and like. Okay, give me 1 second. We'll go to the next question. Let's see how long we've been running right now. We're going about an hour and a minute, so I'm going to do a few more and then decide whether to go an hour and a half or not. But we'll maybe go an hour and 10 minutes or an hour and 15 minutes for sure. Because I don't want to make this into 4 parts. There's a lot. We've only done about 25% of the problems so far, or even less than 25% of the problems. So it'd be nice for me to squeak this into maybe 3 parts. But if I need doing 4 parts, that's good too. Because if I do like a 2-hour session, people don't want to watch it through. All right. So 17. The area of the triangle below is 2/5 square foot. And we're going to look at the illustration first. There's a triangle. It looks to be a triangle. Maybe it wasn't. if you notice here, there's a thing there, which means this is 90 degrees. Okay, it's telling us this is the base. This must be the height then. Okay, so we know the area of a triangle equals 1/2 base times height. And by the way, if you go back to the reference sheet, that was one of the things they originally gave us in the formulas. But you guys should know this, and you should be fluent in how to use it as well. All right, let me center this back. And let's just double check. They're giving this in feet, and this is in square feet. So units are good so far. What is the area? So they're giving you the area in this case. And then they want, what is the length in feet of the base? So we're trying to look for what the base is equal to. And again in feet. So there's no unit conversions here. So let me rewrite the area formula out. So they're telling us that the area is 2/5. Okay, and what we're going to do is drop down each part. So 1/2 is still 1/2. The base is what we're looking for. And the height is 6/5. All right? So all we have to do now is solve for B. So this was a 2, 1/2. Okay? So I can take the 2 into 2 once, 2 into 6 3 times. So that means we have 2/5 equals 3/5 B. Okay? All I did was take this 3/5 and put it in the front because this 1/1 gets thrown away. So all I did was like A times B, I made it B times A. Okay? Oops, I don't know why that did that. All right, so now we need to get B by itself. So to do that, if I have 3/5, if I multiply this side by 5/3, this 5, that 5, and this 3, and this 3 cancels. So whatever I do to the right-hand side, I do to the left-hand side. So I get 5/3 here as well. Okay, this 5 cancels, and we end up with 2/3 equals B. Okay, which turns out to be choice C. Okay, we have the answer, so let's plug it into the 1/2 BH stuff. Let me scroll this up slightly so we have a little more white space. So what we're going to have is, again, area equals 1/2 BH. Okay, and they're telling us it's 2/5. Equals 1/2. The base we decided was 2/3. And the height was 6/5. Okay, we can cancel stuff out here if we want. This 2 goes rid of that 2. This 3 goes in here twice. And this is 1/1 then, that goes away. This is 1/1, that goes away. And all we're left with is 2/5, which is what we're looking for. So we're able to confirm that that is what happened. Okay? I'm going to try to do maybe 2, figure out if we can squeak through doing this in 3 parts instead of 4. Okay, so this one is odd. I already see it's a word problem. I see it's involving fractions. And I see the answer choices involve a bunch of expressions. So we already saw this once. We saw this yesterday too. So from this grade on, the problems are oriented where they're going to ask us stuff like that. And what normally happens is, if you took the word problem and solved what they're asking you for, normally the answer goes a few steps further than the choices they give you, okay? In that case, you have to look for any temporary answers. The other thing they do is sometimes they give you something conceptual where there's actually no concrete number at the end. Like you don't get 9 at the end of it. You get like 8 plus 9 or something like that, where it's just incomplete. But even at that level, there might be temporary steps where that's one of the choices they're giving it to you. So these get hard, not only because the answers are abstract, as in they're just expressions, but they're also hard because you don't know what form they're looking for. Normally, when you're given a problem, you're asked to simplify it. Well, on these kind of questions, you're not asked to do that. You're just asked to find out which one matches what should be the case here. All right, so let's take it a sentence at a time and a phrase at a time. So the weight of an object on the moon, okay, and that weight we're calling m, is about 1/6 of the object's weight on Earth, E. Okay, so is means equals. Okay, so they're saying m is about 1/6 of the weight on Earth. So they're saying the weight on Earth is E. Okay, m is the weight on the moon. M doesn't represent moon. M represents the weight on the moon. And E doesn't represent the Earth. It represents the weight on the Earth. Okay, so which equation represents the approximate weight? So this is about and approximate. So we can even put like a little tilde here. M is about 1/6 of E. Okay, in terms of the object's weight on Earth. All right. So it turns out we already wrote the answer. So which of these matches that? Okay, it looks like none of them does, right? Do you see 1/6 E anyway? And there's 1/6 plus E. So for that reason alone, that choice A would be no good. M is 6 plus E, so that looks ridiculous. Okay, and then we're left with the ones involving multiplication, which is 6E and E over 6. Well, does it say that the weight on the moon is 6 times the weight on the Earth? No, but that's what D says. All right, so D can't be the thing either. Now, what about E over 6? Is that the same as 1/6 over E? Now, a lot of kids get their brains turned to jelly on something like this. And it turns out it is, because any number is itself over 1. So that means the number E, and we're using it symbolically, E is the same as E over 1. So doesn't it follow that 1/6 times E, which is what we originally had here, is the same as 1 over 6 times E over 1? And if we multiply that out, we get 1 times E is E, and 6 times 1 is 6. So it turns out that something like 1/6 E is equal to E over 6. Okay? So that means M is also equal to E over 6, which turns out to be choice B. All right? So be careful. And by the way, this concept of any number being itself over 1, this mind blows a lot of kids, especially when you're solving algebra. If I have like 9 equals 1/5 x plus 2, right? A lot of kids don't realize this is the same as x over 5. Okay? These two things are substitutes for each other. You're allowed to replace those. Why? Because x is the same as x over 1. So if we multiply it the same way we did here, you get x over 5. Okay? And it's a shorthand. So this original equation here is the same as 9 equals x over 5 plus 2. These are both the exact same equations. So be careful when you see stuff like this. And in fact, if I beat this to death slightly, and I believe I did a SHSAT session on this, where like these are all equivalent. So I have 1/2 x. That's the same as x over 2. Okay? And that's the same as 0.5 x. Right? These are all the exact three things. That's a half, that's a half, and that's a half of x. They're all the same expression, even though they're written differently. Okay? It's almost the same, like I can have a half, and I can say it's equal to 3/6, especially if you simplify it. It's not exactly the same, but it's the same notion that we have mathematical identities, mathematical equivalencies, and things like that. Okay? Okay, we have an illustration. We have what looks like a rectangle with a diagonal drawn through it, which seems to be making it into two triangles. It looks like the width, which is the number down here, of the rectangle is 1.5 feet. The length of the rectangle is 4 feet. They're both feet, so far there's no unit conversion. And always worry about your unit conversion, whether they're going to happen or not. Okay? So it looks like I'm going to make a wild guess that they're going to ask us for the area of one of the triangles. So let's call this triangle over here A, and this triangle over here B. I don't know where they're going with this, but the whole area of the rectangle is 4 times 1 1/6. And by the way, when you memorize the area of a triangle, we're going to take a little sidebar for a second. That may or may not have to do with this problem. The area of a triangle is 1/2 BH. And if we look at this rectangle, that's exactly what's happening here. The height was 4, the base was 1 1/6. And A is half of that. B is also half of that. So that's where the equation of the formula of the area of a triangle comes from. Because it's half of what a rectangle is. So that's one way to memorize it if you want to. Okay, so they tell us that's 4 and that's 1.5. We don't know what to do with it yet. So Theo made the sails for a model boat. Cool. So we cut that in half and he made 2 sails apparently. He cut along the diagonal. So now we're confirming it is a diagonal of a regular piece of cloth to make 2 sails. Okay, I wish they had said this was a rectangle. We know that this is 90 degrees. It would have been nice for them to put another one up here. Okay. But in any event, we know since there's a 91 here and there's something here, we know for certain that A is a right triangle. Okay? Okay, what was the area and square foot of one cell? So we went through that already. So it's going to be 1/2 times 1 1/6. So we're going to make that 7/6 times the height, which is 4. Okay? We're going to take this 2. 2 goes into 2 that. This becomes 2. And we get 14/6. Okay, let's see what our answer choices are. Sometimes they want us to simplify this, and sometimes they don't. In the event that was 14/6. I'm not sure what the target is yet. So that's going to be 2 and 2/6, which is 2 1/3 then. So then the answer would be D at that point. All right. So this took up a page, but there's really nothing going on here except for them asking, what is the area of A? And it turns out triangle B, if this is truly a rectangle, is the same size. They're both 2 1/3. Okay. Okay, so this looks like a very different kind of a problem. Okay, so we're going to go look at the illustration. This looks like a volcano. The summit means the top of the volcano. This is sea level. So apparently there's water here, and the volcano is in the middle of the ocean. It's not on land. And some of it goes below sea level. So this is 5. So that means the length of this here is 5 kilometers. Okay, that's what it's telling us here. The floor, from the floor to the sea level, right? Because it says the ocean floor is here. That's the red line. It would have been nice if they labeled out a little better, but that's okay. And it says that means this implies, having this in the parentheses way, that the ocean floor is 5 kilometers below sea level. So sea level is normally considered 0, right? So it's 5 below. Technically, this is -5 then. Okay. What do we know about the summit? Nothing. Okay. There is some clouds coming off of here. Maybe they're going to evolve that. But so far, the info we've been giving seems to imply something's going to happen either based off the sea level or based off the ocean floor or based off of both of them. All right. We're given no information about the width, this width of the volcano. So that's probably not where they're going here. And by the way, remember, just as a sidebar thought, if this is where this problem is going, it's sometimes handy to view some of these problems like a number line on its side or a thermometer. So this is 0. This is -5. Okay. The summit, we don't know what that is yet. Okay. All right. So keep that handy. So this is really a number line problem in disguise. Okay. So the summit of the volcano is 10 kilometers above the ocean floor. So this is probably the first error a lot of kids make. They probably go and say, oh, this is 10. Okay, it's not 10. Does anybody know why? In other words, if I put this on the thermometer here, it's not 10. It's not 10 because it doesn't say it's 10 kilometers above the sea level. It says from the ocean floor. So if this was already 5, then to get to here, we have to go another 5. Okay, so it turns out that this is actually 5. So the summit is 5. Right? We can feed that big in. The summit of the volcano is 10. 5 plus 5 is 10, as shown below. Cool. So if the ocean floor has an elevation -5 kilometers, which statement describes this here? And that's kind of what we did with the thermometer here. All right? And that's all there is to this. So there's a whole bunch of cryptic kind of stuff now in the choices. Let's see if we can kind of decipher that. By the way, notice there's a pattern in the answers. This happens a lot too on these. That A goes from sea level 0, C is sea level 0. B goes sea level 5, D is sea level 5. And then there's a second half. There's two parts to this. There's this and the second half of each one. The elevation's 5, the elevation's 5. The elevation's 10, the elevation's 10. All right? So this gets, I already had that set. Let me refix this. So now that we understood that the summit is 5 above the sea level and 10 above the ocean floor, let's try to process this. So A, the elevation of the sea level is 0. True. So we're doing a truth table is basically what it is. So this is true. And the elevation of the summit is 5. That seems true. So I believe the answer is A already. Let's look at the other options. The elevation of sea level is 5. That's wrong. So it doesn't even matter. It says the elevation. This is true. But this is false and true, so this is false. Okay? The elevation of the sea level is 0. True. And the elevation of the summit is 10. False. So this is false. Okay? The elevation of the sea level is 5. True. And the elevation of the summit is 10. False. So true and false is false. Okay? So the answer there is D as well. All right? Let me try to get 2, and we can maybe do this in 3 parts then. And there's 2 questions on this page, so we might end at this page because I don't want this session to be that long either. Plus, I have other stuff to do. All right, so we're going to look at the figure. So this is a busy page. There's an illustration. There's a bunch of words with a bunch of numbers thrown in them. And the answer choices are a bunch of equations. Yaka, yaka, yak, right? So we're going to start out with the illustration. So what is in this chart? It's about roller skating costs. The left column is the number of hours, and they're calling that H. It's the number of hours you roller skated, apparently. The total cost is C. So if, for instance, you roller skated for 1 hour, it's going to cost you $8. If you roller skated for 4 hours, it's going to cost you $17. There's really nothing else to total here because this chart seems to be based on the number of hours you did something. There might be a pattern here. Can we see what the pattern is? Obviously, 1 versus 8 is times 8. 2 versus 11 is not times 8. 3 versus that is times 3 plus 2 maybe, or times 4 plus 2, or times 4 plus the thing outside of here. All right, so we're trying to see a pattern. I'm not sure what the pattern is if there is one. So I'm out of ideas, and I think I understand the table enough. Now go look at the words. The Frenchtown roller skating rink charges a $5 entrance fee and an hourly rate on top of that for roller skating. Cool. I think I buy that, especially based on what I know about the table. And I'd like to make a relationship that where it says the $5 entrance fee is this. Whereas if you didn't skate any hours, it still costs you $5 just to enter the place. Okay, and then stuff kicks in. So I think there's a $5 on top of each of these. In other words, if you minus 5 of here, and you get 3, that might mean the hourly fee is 3. Okay, and I'm wild guessing here. In fact, let's try it. If I minus 5 from here, I get 6. Yeah, 3 times 2 is 6. If I minus 5 from here, I get 9. Yep, 3 times 3 is 9. And if I minus 5 from here, I get 12. And yes, 4 times 3 is 12. So that means my cost is equal to 3 times the number of hours plus 5. Okay, and I'm doing this without knowing what the question is. I'm just trying to understand it. So the total cost of the roller skating rink depends on the number of hours a person skates. Cool. And by the way, that doesn't violate the temporary answer I've come up with so far. The table below shows the total count of skating for the different number of hours. Cool. So let's scroll up so we can kind of get the answer showing. Okay, which equation represents the relationship between the cost C and the number of hours H? Okay, so choice A says 8H. No, it's not. That even fails in the first one. It's not 8 times 0. and 8 times 4 is 32. So it's not A. Okay. Choice B, does that look like what I wrote it here? No, it doesn't. It's a little backwards. So 5 times H, if we use the first example, is 0, plus 3 is 3, but it turns out to be 5. So that doesn't work. Let's just double check it by using the last one. 5 times 4 is 20, plus 3 is 23. It doesn't work. Goodbye, B. So long, fella. Okay? C says 2H plus 7. So again, if we use the 0 case, we get 2 times 0 plus 7 is 7, but it's 5. So that doesn't work. Let's use the last choice again. 2 times 4 is 8, plus 7 turns out to be 16. So for that one, it does work. So let's try another one. 2 times 2 is 4, plus that is 11. So that seems to work, but it doesn't work for the 0 case. So C is still no good. And then D says the 3H plus 5, and I already went through each choice with that. So we know the answer there is D. Okay? This is a time waster kind of a problem. But if you know the pattern and get used to it, you can get comfortable with it. Okay, Fei Yen's dog eats 8 ounces of dog food. So this is a word problem each day. So 8 ounces each day. That's our ratio. 8 ounces. And I don't know where the problem's going, so I'm just going to kind of annotate maybe where it's going. What's going on with this tablet? It's not writing. The tablet's getting tired. Over 1 day. Okay, Yen bought 28 pounds of dog food. Cool. This is bite-sizable. I understand each statement. How many 8-ounce servings are in 28-pound bag? So there's 2 ways to go about doing this. We can convert ounces to bags, so we'd have to do unit conversion. Ounces to pounds or pounds to ounces. This is similar to the example, I think the very first example, that if you know, again, based on your reference sheet, which you should have memorized, that it tells us 1 pound is 16 ounces. Okay. Where are we? I lost the problem. So another way to ask the question is if 8 ounces is half a pound, right? How many half-pound servings are in a 28-pound bag? The answer has to be 56, right? If it was 1 pound servings in a 28-pound bag, you get 20 ounce servings, 28. So if it's half of a pound, then you get 2 per thing. You get 2 servings per pound. So it's 28 times 2 or 56. The other way is to convert this to 28, convert this into ounces. So we're going to multiply that by 16. All right? And then divide by the number of ounces. That's a 6. And it turns out it balances out. So some of you are actually going to multiply 28 times 16. But why not take the 8 into 8 once, 8 into 16 twice, and we still get 28 times 2 equals 56. So we still get the same answer. All right? Let me just take a peek at the very next question, because I might do that just to try to slight leg up, so that we can see we did that. Yeah, let's do this problem and make it the last one. And again, if you guys have any questions, please ask. Subscribe and like, email me, whatever, yada, yada, yada. Okay, this is a number line question, even though it's based on a word problem. Point A and B are placed on a number line. So we have a number line. We don't know what's where. So point A is located at -20. So let's say this is 0. It says A is over here at -20. This is A. And B is 5 less than A. So if B is 5 less, then it's got to be over here. In fact, it'll be -25. Right? So let's go through it again. Point A and B are placed on a number line. Cool. Point A is located at -20. Cool. And point B is 5 less than point A. Cool. So which statement is true about B? Not about A, but about B. It is located at 25. And by the way, there's another truth table here again. You notice we have this here. So there's this I part and I part. So both of these must be true. It is located at -25, true. And it is to the right of A. No, that's false. So therefore, true and false is false. So A is no good. It is located at -15. So if you notice, they're flicking between -25 and -15 again. So there's always this kind of duality that happens even within the truth table. Is often used mechanism in a lot of these questions. Okay, so they're using -15. Can we double check that that's actually the case? Let's go reword the words and make sure that it really is 25. Point A is -20 and B is 5 less, right? So it's 5 less. So it's -20 minus 5. -20 minus 5, which is -25. Okay? Remember the larger the absolute value of a number goes when it's negative, the more negative it is, which the more negative something is, the smaller it is. That's different than this side when we have the pluses, right? 20 plus 5 is 25. But this is -20 minus 5, which is -25. All right, so B is out. Okay, so that same notion, D is out. So it is located at -25 and is to the left of A. Booyah, we got it. All right. All right, yeah, let's put this to a rest. We're probably gonna do some 3 parts then. Again, I'm Greg from GregsTutoringNYC at gmail.com. You guys can check out my website, GregsTutoringNYC.com. Yeah, we're going on an hour and a half, so we're gonna end this. I'm exhausted, so we're gonna do part 2 whenever I get a shot to. Probably tomorrow. Maybe I might even do it overnight so you guys can get a glimpse out of it and do a quick review through. Some of you are starting your state test tomorrow, usually after school. Some of you are doing it on the weekend. There's lots of mayhem kind of progressing around it this year based on the pandemic and delayed school reopenings and kind of things like that. All right. In any event, peace out.